Hey everyone, and welcome back to the channel. Today, we're going on an incredible journey, not to a distant galaxy, but right above our heads. We're going to explore something we live in every single day, yet often take for granted: Earth's atmosphere. It's this amazing multi-layered blanket of gases that makes life on our planet possible. It gives us the air we breathe, protects us from the harshness of space, and even creates the weather that shapes our world. So, buckle up as we peel back the layers of our sky one by one. Let's start at ground level, in the layer we all call home, the troposphere. This layer extends from the Earth's surface up to about 12 kilometers, or around 7.5 miles. Think of it as the planet's bustling lower floor. It's where we live, where planes fly, and where almost all of our weather happens. Clouds, rain, snow, wind, thunderstorms, it all brews right here. The troposphere contains about 80% of the atmosphere's total mass and nearly all of its water vapor. As you go higher up in this layer, the temperature drops. That's why mountaintops are so cold. It's this constant mixing and churning of air, driven by the sun's energy, that creates the dynamic weather patterns we experience every day. Now, let's ascend to the next level, the stratosphere. This layer sits right on top of the troposphere and stretches up to about 50 kilometers, or 31 miles above the Earth. It's a much calmer place than the turbulent troposphere below. The air is thinner and there are very few clouds, but the stratosphere holds something incredibly important: the ozone layer. This isn't a solid layer, but a region with a high concentration of ozone gas. You can think of it as Earth's natural sunscreen. It absorbs the majority of the sun's harmful ultraviolet or UV radiation. Without the ozone layer, life on the surface would be exposed to dangerous levels of radiation, causing major problems for plants, animals, and us humans. Interestingly, unlike the troposphere, the temperature in the stratosphere actually gets warmer as you go higher. This is because the ozone molecules are absorbing that UV energy from the sun and releasing it as heat. Climbing higher still, we reach the mesosphere, which extends from about 50 to 85 kilometers, or 31 to 53 miles, above our planet. The name meso means middle, and this is indeed the middle layer of our atmosphere. If you've ever seen a shooting star, you've witnessed something happening in the mesosphere. These bright streaks of light are actually meteor-small rocks and dust from space burning up as they hit our atmosphere. The friction with the air molecules in the mesosphere heats them up so much that they glow brightly before disintegrating. The mesosphere is also the coldest part of Earth's atmosphere. Temperatures here can plummet to an incredibly frigid -90 degrees Celsius or -130 degrees Fahrenheit. It's a harsh, cold, and incredibly thin environment. But it serves as a crucial shield, burning up millions of potential impactors every single day, ready to go even higher. Our next stop is the thermosphere. This layer is vast, starting at about 85 kilometers and extending all the way up to 600 kilometers. or about 370 miles, into space. The air here is extremely thin, with gas molecules spread far apart. But what's fascinating about the thermosphere is its temperature. The name thermo means heat, and this layer can get incredibly hot, reaching temperatures of 2000 degrees Celsius or more. Now, you might be thinking, wouldn't anything in there just melt? Well, not exactly. Temperature is a measure of the average energy of particles. The particles here have a lot of energy because they reabsorbing high-energy X-rays and UV radiation from the sun. But because the air is so thin, there are very few of these hot particles to transfer that heat to an object. So you wouldn't actually feel hot. The International Space Station and many satellites orbit the Earth within the thermosphere. This is also where the magic of the auroras happens, the northern and southern lights. When charged particles from the sun collide with the gas atoms in the thermosphere, they get excited and glow, creating those breathtaking displays of light in the polar skies. Finally, we arrive at the outermost layer of our atmosphere, the ozone. This is the final frontier, the very edge of our atmosphere, where it gradually fades into the vacuum of space. The exosphere starts around 600 kilometers up and can extend for thousands of kilometers. There's no clear upper boundary. The air is so incredibly thin here that it's barely there at all. It's mainly composed of the lightest gases like hydrogen and helium. Atoms and molecules in the exosphere are so far apart that they can travel for hundreds of kilometers without colliding with one another. Some of these particles are moving so fast that they can even escape Earth's gravity altogether and drift off into space. It's a slow, constant leakage of our atmosphere into the cosmos. It's the whisper of our planet's breath as it meets the vast emptiness beyond it. So there you have it, a journey through the 5 major layers of our atmosphere, from the weather-filled troposphere, where we live, to the protective stratosphere with its ozone layer, up through the meteor-burning mesosphere into the hot aurora-filled thermosphere, and finally out to the exosphere where our world meets space. Each layer has a unique and vital role. Together, they create a complex, dynamic system that not only protects us, but makes our planet a vibrant, living world. It's an intricate shield, a life support system, and the stage for some of nature's most beautiful phenomena. The next time you look up at the blue sky or a starry night, remember the incredible layers of air stretching hundreds of kilometers above you, working silently to keep our planet safe and habitable. Thanks so much for joining me on this atmospheric adventure. I hope you found it as fascinating as I do. If you enjoyed this video and learned something new, please give it a thumbs up, and don't forget to subscribe and hit that notification bell so you don't miss our next exploration. What part of our planet or the universe should we explore next? Let me know in the comments below. Until next time, stay curious.